All right, so one of the new topics for the IB program for HL is we're looking at binomial theorem, the binomial expansion, when n is a rational number. Okay, so you've seen things like a plus b to the n is what we're talking about. And you should be very familiar before you watch this video on how to do this when n is a positive integer. Okay, so if I have a plus b to the 10th power, you should be able to know how to get each individual term of that. I don't know that I'd make you find all 11, and I don't know that IB would make you find all 11, but you should be able to find a particular term and something like that. Well, now what they've added to the curriculum is what happens when this is not necessarily a positive integer, when it's just a rational number. Okay, and so the first thing I want to talk about in this is how to find a combination when n is a rational number. Okay, so you remember combinations. I typically use this notation. IB has used this a bit, where it's n over r and parentheses like that. It looks like either a little matrix or it looks like a little vector. It's not. We use the same notation to mean different things. You have to know it in context. Okay, they'll also write it this way, NCR, and that's what your calculator kind of looks like. Just a reminder. If you're trying to do this, we go options right here to probability, go over to probability, and then here's NCR. So if I'm going to do 5, choose 2, then I can type that in like that. The thing that's exciting is that we're gonna do a problem in just a second where it's like 0.5, choose 1, and it doesn't know how to do it. So you are about to be smarter than your calculator. So isn't that exciting? Okay, so let's talk about this a little bit. As we get started here, this n choose r is equal to n factorial over r factorial n minus r factorial. Okay, that's what it's defined to be. And so we've just done this sort of thing in the past. Well, if you remember, this n factorial means it's n times n minus 1 times n minus 2 times when we can keep going all the way down until we get to 1. Okay, so actually that's not what I want to do. What I want to say, that's not wrong, but I forgot where I was going. This becomes, we get all the way down till we have n minus r factorial, wherever that falls. Okay, and then when I look at this, here's r factorial, and then we still had this n minus r factorial. Well, when we write it out this way, we can see that this would cancel, all the n minus r factorial would cancel with n minus r factorial. Okay, so what we end up getting is that this would be equal to n times n minus 1 times n minus 2 times, we keep going until we get one bigger than that. Okay, and one bigger than that is n minus r plus 1. And all of that, so this canceled, these canceled, they're gone, and the term, the penultimate term, no, just kidding. Well, the term that came right before the n minus rth term is n minus r plus 1, and so now we're left with this. So with these rational exponents, we're going to use this version of the formula. And so what we want to consider is, so say something like, say I've got 1/2, choose 3. Okay, so what we know here on this one is that our r value is equal to 3. Okay, so we're going to take n, which is 1/2, and then we're going to multiply it by 1/2 minus 1 times 1/2 minus 2, and we're going to go all the way down until, well, let's plug in 3 right here and see what we would get. So if I have n minus 3 plus 1, that means n minus 2. So that means that the last term that we want is n minus 2. So this would be, so using this formula right here, we're only going to have these first 3 things that we're multiplying, because when I plug in 3 right here, I have, like off to the side, this would be n minus 3 plus 1, which is equal to n minus 2. So the last one that we stop, the one that we stop with is, it's based on this 3, and this over here. And to be honest with you, I was struggling through some of these problems yesterday, and I finally was able to get the answer that the book was getting, or that Wolfram Alpha was getting, but I didn't understand why. I go home, I eat dinner, I go to rehearsal last night, I played cello in the orchestra, and I'm driving home from an hour and a half long rehearsal of, we're preparing for a Veterans Day concert, and all of a sudden it dawns on me as to why it would stop here. So I've struggled to know how many of these products do I need, but what you want to think about, it all of a sudden was perfectly obvious to me driving home at about 9 o'clock last night. So plug in 3, or plug in whatever this R value is, and to figure out what the last one you want. Okay, so that means my N value is 1/2 times 1/2 minus 1 times 1/2 minus 2, and this one is the last one that we want, and then we're dividing it by 3 factorial. Okay, so in this one we have, this is now 1/2, this would be a negative 1/2, this would be, what is that, negative 4/2, so negative 3/2. And this is divided by, well, 3 times 2 times 1 is what 3 factorial is equal to. Okay, so another way to think about this is, however you get here, and this is being multiplied by 1/3 times 2. Okay, so does anything cancel? The 3 here will cancel with this 3 here. And then I have a negative times a negative is a positive. And then I have 2 times 2 times 2 times 2. This is 2 to the 4th. So I have a positive 1/16. Okay, and did I do that correctly? I think so. Your calculator won't do this for you, but Wolfram Alpha will. So I was playing with that on my computer. Do I have that open still? Hang on. Update later. What did I have? I had 1/2, comma 3. So I went to Wolfram Alpha and I plugged this in a combination of 1/2, comma 3, and here's how they inputted it, and they just got the value of 1/16. And there's the decimal form. They have all this other stuff, which, okie dokie. So, but the short answer is your calculator won't tell you how to do this. You have to know how to do it, but Wolfram Alpha can let you know if you're correct or not. So luckily, I just got the same thing Wolfram Alpha did. So I would encourage you, go practice these, kind of wrap your head around this. If we have, well, let me say this before I stop the video. When R is equal to 1, then what we're going to have, we're looking at this right up here. Well, if I have n minus 1 plus 1, that's n minus 0 or plus 0. So all I need is this. So when that's the case, then I have n over 1 would be equal to, n times 1, I lied, n over 1 factorial. Okay, when the R value is equal to 2, well, come back to this, n minus 2 plus 1, that means n minus 1. So that means I'm going to have this term and that term, and this will be a 2 down below. So n, whatever that n value choose 2 is going to be equal to n, sorry, you can't see what I'm doing, n minus 1 all over 2 factorial. And then we did the one with when R was equal to 3. So that's n choose 3 is going to be equal to n times n minus 1, times n minus 2, and that's all divided by 3 factorial. Okay, so that made a little bit more sense to me as I was driving home from rehearsal last night, which reminds us that we need to give our brains time to process through things. So I had worked on it a bunch during school, went home, did other things, went to rehearsal, thought about entirely different things, and then all of a sudden everything clicked. So got to give your brain time to do that work. Don't try and cram. It doesn't always work. Anyway, good luck. Go practice.